Bismillah Rahman Rahim. Assalamu alaikum. Welcome to ASTC. This is Cambridge A Level Mathematics 9709 Mechanics. So today we will be continuing from where we left off in our previous video. So let's get started. Example 1 is a particle P of mass 4 kg is moving with speed 4 meters per second on a smooth horizontal plane. Okay. A particle q of mass 5 kg rests on the same plane. So rests means that its initial velocity is 0. Particle p collides with particle q and after the collision q after the collision q moves off with speed 3.5 meters per second. Okay, so this is the situation that we have right now. Before the collision, p is moving towards q, which is at rest. Okay, and the velocity of p is 4 meters per second. After the collision, it says that the final velocity of p, that is what we need to find, and the final velocity of q is 3.5 meters per second. So we have taken right hand side to be our positive direction. Okay, so first of all we're going to write total momentum before impact is equal to total momentum after impact. Okay, so that will be the initial momentum of p plus the initial momentum of q equals to final momentum of p plus final momentum of q. See, these are the values. 4 times the mass of p, which is also 4, and this will be 5 multiplied by 0. Then over here we have 4, which is the mass, multiplied by vp, that is what we need to find, plus 5, which is the mass of q, multiplied by 3.5 meters per second. So when you simplify, you're going to get the final velocity as minus 0.375 meters per second. So this minus indicates that the direction has been reversed. So P is moving towards left. All right, example 2. A particle A of mass 2 kg is moving with speed 4 meters per second on a smooth horizontal plane. A particle B of mass 3 kg is moving in the opposite direction with speed 3 meters per second on the same plane. Okay. Particle A collides with particle B, and after the collision, A moves off with its direction reversed with speed 3 meters per second. Find the speed and direction of motion of B after the collision. So A and B are moving towards one another. The direction of motion of A has been reversed. So what's going to happen to B? So let's just say, if we assume, because we have to take a direction, right? So let's just say that I'm going to say that, okay, it's moving in this direction. So anyhow, this will be VB, which is the final velocity of B. If the value of final velocity of B turns out to be positive, that means that this assumption is correct. It is moving to the right hand side. However, if this assumption was wrong, then your value is going to be negative. So that will automatically tell you that, okay, the direction is going to be towards left. Okay. So again, we have total momentum before impact equals total momentum after impact. So we have initial momentum of A plus the initial momentum of B. So that will be 2 times 4 plus 3 times 3. Sorry, 3 times minus 3. Okay, because the direction is negative. Then that will be equal to 2 times minus 3. Okay, because the direction is has been reversed, plus 3 times VB. Okay, so when you simplify, you will get 1.67 meters per second. So that means our assumption was correct. The direction of motion has been reversed and the magnitude is 1.67 meters per second. Okay, a child of mass 30 kg running through a supermarket at 4 meters per second leaps onto a stationary shopping trolley of mass 15 kg. Okay, so a boy starts running towards the trolley and starts grabbing it. Okay, The trolley is stationary, so its initial velocity is 0. The boy is running at 4 meters per second and his mass is 30 kg. Find the speed of the child and the trolley together, assuming that the trolley is free to move easily. So basically, there are no frictions, okay? There are no frictional forces. There is no resistance. So what we can see here is initially the boy and the trolley, right? They were separate, but after impact, you could say they have coalesced. Okay, so coalesced, we studied about this, right? That it means that they have joined together. Now we have a combined mass. So after the collision, the situation will be that now you have a combined mass of 45 kg and it will be moving towards the right. So you need to find its velocity. So 45 kg will be 30 plus 15 kg. Taking the direction of the child's velocity as positive, so we are taking right hand side to be positive, the total momentum before impact is equal to this much. So they, and now in this example they have calculated the initial momentum or the momentum before impact separately. So that will be 30 times 4 plus 15 times 0. So 13 times 4, that will be 120 Newton seconds. The situation after impact is shown in figure 10.6. So now this is the situation that we have. After impact, the final momentum will be 45 times V. So that will be 45 V Newton seconds over here. After that, the conservation of momentum tells us that the total momentum before impact is equal to total momentum after impact. So that's how we will equate both of these. So V is equal to 2 upon 3 meters per second. Okay, two smooth spheres A of mass 2 kg and B of mass 3 kg of equal radii are moving towards each other along the same straight line on a smooth horizontal plane. Sphere A has velocity 7 meters per second and sphere B has a velocity of 2 meters per second. After the collision, the sphere B moves in the opposite direction with a speed of 2 meters per second. All right. Find the velocity of sphere A and the loss in kinetic energy of the system. So A and B are moving towards one another, and the direction of B, sphere B, has been reversed. Okay. All right. So this is the situation before collision, and this is the situation after collision. So here we can carry out the same concept. Total momentum before equals total momentum after. You have 2 times 7 plus 3 times minus 2 equals 2 times v plus 3 times 2. So when you simplify, your velocity will be 1, and since it is positive, that means it is to the right hand side. So the final velocity of A is 1 meter per second. Now we also need to find out the loss in kinetic energy of the system. So we discussed this in our previous video that if I want to find out the change, right? Now the change in kinetic energy will be final kinetic energy minus initial kinetic energy. Okay, and that will give us a negative value because there has been a loss in the system. But if you directly say loss in kinetic energy, then you can simply subtract the magnitudes. Okay, so for example, if we work out the initial momentum, so total initial momentum will be the initial momentum of A plus the initial kinetic energy of A plus the initial kinetic energy of B. Okay, so that will be half m times 7 square, half into 3 times 2 square, that will be 55 joules. Then total final kinetic energy will be less. So that will be half times 2 into 1 square plus half times 3 times 2 square equals to 7. So the final kinetic energy of A is this plus final kinetic energy of B will be worked out from this. So the formula that we are using is half mv square minus, sorry, that's it. I mean, half mv square plus half mv square. So this one is for A and this one is for B. Okay. Now we have already mentioned that it is going to be a loss, so we can only work out the magnitude. So just subtract the values. Okay, find the difference. That will be 48 joules. However, if the question asks you to find the change in kinetic energy, then the change in kinetic energy will be kinetic energy, which is the final kinetic energy, minus initial kinetic energy. In that case, this would be 7 minus 55, and that would be minus 48. So the change would have been negative in that case. All right. Remember, kinetic energy is a scalar, so it doesn't matter that the spheres are moving in opposite directions. When we are doing our calculations related to kinetic energy, right? So here we are actually taking speed. So V is actually speed. So basically what we're trying to say here is that V is just the magnitude. We are only talking about the magnitude of velocity, not the direction, because energies are scalar quantities. So it doesn't matter whether the object is moving to the right or to the left. Now, the second part of the question is, after the collision with sphere A, sphere B collides with sphere C of mass 1 kg, which is moving in the same direction as B with velocity of 0.5 meters per second. So after the collision, B started to move towards the right, right? After that, now it is colliding with another sphere C, which was already traveling in this direction. So once it has collided, then what happens? The spheres coalesce to form an object D. So now after collision, you can say they have combined. So yeah, that's why you'll have a mass of 4 kg, because that is 3 kg plus 1 kg. Okay, so now we need to find the velocity of D after this collision. The velocity of D after the collision. So that will be total momentum before impact equals total momentum after impact. So that will be 3 times 2 plus 1 times zero point 0.5 equals 4 times V. There you go. So V is going to be 1.625 meters per second. All right, here it says a common mistake is to try to use kinetic energy before equals kinetic energy after to solve problems on collisions. This is wrong because energy is usually lost as heat and sound. Okay, example 3. Two particles A and B of masses 7 kg and 9 kg respectively are connected together by a light inextensible string. The particles are at rest on a smooth horizontal surface with the string slack. Particle A is projected away from particle B with speed 4 meters per second. Find the speed of the particles when the string becomes taut. Okay. All right. So now this is a kind of a different situation, but it is still related to momentum, right? So you have two particles A and B connected through a light inextensible string. And when it says that it is a slack, that means that it is loose. It's not held tightly, right? So what happens is this particle A is projected away from particle B with a speed of 4 meters per second. So that means the velocity of A is going to be 4 meters per second away from B. So that will be towards the left. Okay. Find the speed of the particles when the string becomes taut. So while the initial velocity was given to A, B was at rest at that point. So therefore, its initial velocity is going to be 0. Now, we need to find out that what will be the velocity of the particles, okay, that the final velocity of the particles once the string becomes taut. So that will be total momentum before equals total momentum after, and here we are taking left hand side to be our positive. So this will be 7 times 4 plus 9 times 0 equals 7V plus 9V. Now, why do A and B have the same velocity? Because when the string becomes taut, we assume that because it's light inextensible string, the tension is going to be constant throughout the motion. If the tension is going to be constant, that means that the acceleration is also going to be constant. Okay, the acceleration of the particles will be constant as well. So throughout we are ignoring any frictional losses, any case of any resistances, right? So they have been ignored in this case. So that would mean that both the particles will be traveling at the same velocity. So here v is equal to 1.75 meters per second. Okay, two trucks A and B of mass 4 tons and 5 tons respectively are traveling in the same direction. Truck A is moving at 4 meters per second and B is moving at 3 meters per second. Eventually, the two trucks collide and join together. What is their common speed after colliding? So A and B are moving in the same direction. A has a mass of 4 tons, which is 4,000 kg. B has a mass of 5 tons, which is 5,000 kg. A is moving to the right at the speed 4 meters per second, and B is moving to the right at 3 meters per second. After collision, they combine, so that becomes 9,000 kg, and then now they have a common velocity, which is v. So total momentum before equals total momentum after. You apply the formula, so v is equal to 3.44 meters per second. So they will be joined together after the collision, so they can be considered as one bigger particle moving at one constant speed. What modeling assumptions have been made? Now, when it comes to questions related to momentum, there are some assumptions that we do so that we can simplify our calculations. One of the assumptions is that we are treating the trucks as particles. When we are treating them as particles, that means that we are not taking into account their dimensions. We are considering them to be one single point. So it does not have a length, it does not have a height, uh, it does not have a width, right? So what we are assuming is that it's just a single point, because if you consider an entire object along with these dimensions, your calculations will have some more factors involved. Okay, so that's how first of all we have simplified our calculation. Secondly, we have ignored any sort of frictional effects, okay, because we have assumed that the surface on which the trucks are moving, okay, or the surface on which your particles are moving, that is a smooth surface. Smooth surface means there are no frictional forces, okay, there is no air resistance, there's no frictional forces. So we have ignored these frictional effects and the air resistance. All right, example 5. A bullet is fired from a gun with a horizontal velocity of 800 meters per second. The mass of the gun is 5 kg and the mass of the bullet is 55 grams. Find the initial speed of recoil of the gun. Now, this question is the one where we discussed about explosions. During explosions, what happens? You have one bigger object, an explosion takes place, and now you have two smaller objects traveling in either in the same direction or in opposite directions. Okay, so when we have the example of a gun, so within a gun, okay, you have the gun itself and you also have the bullet inside. After it's fired, a bullet is fired. Now bullet moves on, let's say it is moving to the right hand side. The gun during recoil will move to the left, so they are moving in the opposite directions. So here we can also consider the conservation of momentum. The mass of gun is 5 kg. Its initial velocity is 0. The mass of bullet is 0.055 kg and initial velocity is 0. Total momentum before and then after. Okay, after this what happens? The gun will recoil in the opposite direction to the bullet with a speed of air. Okay, so this is actually the answer. So I was looking at the diagram. So the gun is going to move in the opposite direction while the bullet is going to move to the right with a speed of 800. So you'll do the same calculations. Initial momentum equals total final momentum. Our velocity of the gun works out to be minus 8.8. So this minus tells us that it will be moving to the left. All right. A similar type of question is also here. A rifle of mass 8 kg is used to fire a bullet of mass 80 grams at a speed of 200 meters per second. Calculate the initial recoil speed of the rifle. So it is pretty much the same scenario. So before firing, rifle and bullet have zero momentum because they're at rest. And then after firing, what happens? Your bullet moves to the right with 200 meters per second speed while the gun will recoil in the opposite direction. So total momentum in the positive direction after the firing is 8v plus 0.08 times 200. So for momentum to be conserved, it will be, now this is your total final momentum, that is equal to total initial momentum, that which was zero, okay, because both the velocities were zero. So therefore v is equal to minus 2, and minus means it will be in opposite direction, so that will be 2 meters per second. All right, so that is the end of our chapter on momentum. So I hope that if you had any questions or any doubts, they be cleared by now. In our next videos, we'll be going through some exam style questions, and then in the subsequent videos, we'll be doing some past paper questions. So stay tuned for our next videos.